bit over a year ago, Dave Jones on the EEVBlog channel did a project involving these Russian Nixie tubes, the IN12A, and while looking for a suitable driver for it, he came up with this chip, the TPIC 6B595, and I decided to make a project using the same gear. I also added a couple of neons to provide colons or AM/PM indicators or decimal points, whatever, because these tubes don't contain a decimal point. So I built this project with 6 Nixies, and it was pretty crappy with a homemade board. It didn't work too well. So about a year ago, a bit after making this, I designed some new boards, and about 6 months ago I got them made, and just a few weeks ago I finally got around to putting the parts on them. Now, this is a bit more modular. It uses little boards, each with controlling 2 displays which plug in like these ones did, and these connect together in a chain. Now, with 10 digits in each tube plus 4 neons, we've got 24 bits in that module. So 3 of these chips, which are 8-bit chip registers, gives 24 bits, so that works out perfectly. Every bit is used and we've got full control over every digit. So here's my test rig using 5 of these baseboards. 1, 2, 3, 4, 5. So 10 Nixies in all. So these unplug. I've only soldered 2 of the Nixie pins because they're a very tight fit and the through-hole plating makes good contact, and that makes it easy to desolder them again if I ever need to later. And then these are 3 TPIC. I haven't taken the flux off. Naughty. Yeah. Now, these TPIC 6B595s have a Zener diode on the output, so when the output is pulled low, then full voltage is applied to the digit on the Nixie, but when it's let go, it pulls up to about 50 volts above ground, which is fine for the Nixies. The difference between the 170 volt display and the 50 volts is not enough to turn on the digit. But these neons will work at a lower voltage, so they had to have a 56 volt Zener in series with them, so that even when it was off, it reduced the difference between the 50 volts and the 170, which is 120, reduce that by 56, which is enough to turn off the neon. But then when the output of the chip goes low, then you've got 170 minus 56, which is enough to turn on the neon. A couple of these do seem to be a little bit dicky. They do stay on a little bit when they shouldn't, so perhaps that Zener should be increased even more. But I'll put it back together. Well, just recently I've seen on for sale very similar arrangement to this. I don't think it had the neons, but a pair on a baseboard and 2 Nixies on daughter boards plugging into that. So I didn't pinch their idea, maybe they pinched mine, I'm not sure. So here's my test jig, 10 Nixies, a very cheap and nasty 12 volt 1 amp switching power supply from 240 volts. The 12 volts drives the Arduino, which has a data logging shield which I'm using for the real-time clock with backup battery. The 12 volts also goes to this power supply that provides 175 for the tubes. This is not a very good power supply. It's the inductor gets very hot, as does the transistor and diode. So I'm thinking of replacing it with one of these little guys, which can be got on eBay for only about $8. They can produce up to 390 volts, and I'm sure they can do the current requirement as well. They're quite neat little gadgets, so I haven't tried it yet, but I think I'll replace that lot with this. That was just a circuit I found on the internet, a homemade board I made up for it. So let's turn it on. First it goes through a digit test, trying all the neons and all the digits. Then it starts counting in both decimal, and the neons are counting in binary. Every 5 seconds it doubles the count rate. It just went up then, and then faster, and at the peak it'll get to about 300 updates per second on the units digit. Now 10 digits there is already a bigger number than an Arduino can hold, so the 9's about the maximum you need, so there's not really any need to extend it any further out to the left here, but it could be. I think it'd be interesting to try sticking a few more digits in, see what happens. And we're just about to switch to clock mode. So there we have month, day, hour, minute, second, AM and PM. I'll put the sketch for this project in the description or in one of the comment posts to the video down below. So yeah, I hope you enjoyed this. Catch you later.